Hi, welcome back to our lecture. Let's work with VPCs a little bit hands-on. We're going to create a new VPC and we're going to configure two subnets within the VPC. Each subnet is going to be located in a separate AZ, and one of the subnets will be a public subnet, which is able to route traffic to and from the internet. And the second subnet is going to be a private subnet, which is not able to route traffic out to the internet, at least not on its own. We will configure a NAT gateway within the public subnet, and that NAT gateway will allow EC2 instances configured in the private subnet to be able to route traffic out to the internet. Let's get started. We're going to begin by logging into the AWS Management Console, and we will use the VPC service to configure our VPC resources. I'm going to go to the VPC dashboard. Now, I could launch and configure my VPC using this VPC wizard, but I don't want to do that. I want to show you how to manually configure each of these VPC components, because that's going to be, it's really important that you understand how to do that, how to wire up these components together. I'll start by clicking on the VPC link so I can see the list of VPCs within my account. You notice that there is a VPC already in my account. It's available. And if I scroll here, you'll see that this VPC is the default VPC. Under this column, you see that the value is yes. This is a default VPC within this particular region of my account, which is the US East 1 region in North Virginia. You'll also see that the tenancy for this VPC is the default tenancy. Okay, I'm going to go ahead and create a new VPC, and I'm going to call this VPC the class VPC. So I'll say class VPC for the name. I'm going to give it a CEDAR address block range, which I'm going to use 10.0.0/18 for my CEDAR address block. My tenancy is going to be default. You could change that to dedicated. Remember, if you change that to dedicated, then you're going to incur a big expense. So if you're looking for a quick way to max out your credit card bill this month, then that is a good way to do it. Let's go ahead and create this VPC. Okay, the VPC has been created, and now if I go back to this list, you'll see that I have a new VPC called my class VPC, and it has this VPC ID and CEDAR block range. That looks great. We have our VPC. It's got this CEDAR network address block. We want to partition our VPC now into two separate subnets. I'll click on the subnets link, and you see there's already a set of subnets that are defined, and those subnets are all associated with my pre-existing default VPC. I'll go ahead and create a new subnet, and I will call this my class-public subnet. That is going to be associated with the new class VPC I created. And I want to specify which availability zone it's going to be in, and this one's going to be in US East 1A. I will then also define the network address block for the subnet. I'm going to use 10.0 1.0/24. I'll go ahead and create that. There's one subnet that's been created. You see class public. I'm going to go ahead and create another one called class private. And again, that's associated with my class VPC. For the availability zone, I'm going to use 1B. And my network address block will be 10.0.2.0/24. Go ahead and create that subnet. And now I have two subnets, a public subnet and a class private subnet. If I click on the class public subnet, you can see that I can see some information about the subnet. I want to click on the routing table. And you notice that the subnet is associated with a routing table already. When you create a VPC, it will automatically set up a routing table for you. And the routing table is called the main routing table. That's like it's like the default routing table. And when you create subnets, then by default, it will associate each subnet you create with that main routing table. And the routing table only has one routing rule in it currently. And the rule is saying that any traffic which is destined for a resource within the VPC is just going to be routed locally. Very simple. Now, we're going to be changing these routes here shortly. And because we'll want traffic from our public subnet to be routed out through an internet gateway. We'll want traffic from the private subnet to route through a NAT gateway. So the private subnet will have to use a different routing table. It cannot share the same routing table as the public subnet because they have a different set of rules in place. The next step then, before I set up those rules, I want to set up some additional resources. The next step is I want to add an internet gateway to my VPC. I've created the VPC, I've created two subnets, but if I were to launch an EC2 instance into one of those subnets right now, even if it had a public IP address, it would not be able to route traffic out to the internet because there's no VPC gateway, no internet gateway that's allowing traffic to flow to and from the internet. Let's go ahead and provision that. We'll go to the Internet Gateways link, and we'll create a new Internet Gateway. And I will call it my class Internet Gateway. I'll create it. Now the gateway has been created. When I create the gateway, it's in a detached state, meaning that I've created the gateway, but it's not attached to any VPC yet. Let's go ahead and select that new gateway, and we want to attach it via the actions to a VPC. And we'll select a VPC that we can attach it to. There's only one. Remember, each VPC can only have one internet gateway. In the AWS Web Console can recognize the fact that I have a VPC out there that I've configured that doesn't have an internet gateway yet, and it automatically will list that for me. I'll go ahead and attach it. And now that internet gateway has been attached to my new VPC. Okay. Next, I'm going to launch a NAT Gateway, simply because this can take a little bit of time to provision. And I think this is a good time in the process to create it. I'm going to create the NAT Gateway. This will allow my EC2 instances in the private subnet. These instances only have private IP addresses. It will allow these instances to communicate out to the internet by routing traffic through the NAT Gateway. Let's go ahead and create NAT Gateway. And we're going to create the NAT Gateway. We need to specify a subnet. Which subnet should we put it in? Well, the NAT Gateway needs to be able to communicate out to the internet. Therefore, the NAT Gateway must be in a public subnet. I'm going to choose my class public subnet, and I need to associate it with an elastic IP address. Now, I don't have one I can associate it with, so I'm going to create a new elastic IP. It's created a new elastic IP, and now it's associated it with my NAT Gateway. I'll click on the Create NAT Gateway button, and it's going to create the NAT Gateway service for me, which might take a few minutes. And it gives you this helpful message. It says that in order to use your new NAT Gateway, you need to make sure you edit your routing tables to include a route that will route traffic through the NAT Gateway. We'll set up the routing next. We have our two subnets, a subnet that we call our public subnet and a subnet that we call our private subnet. By the way, just because we named our subnet the class public subnet does not actually mean that AWS is going to treat it as a public subnet. The naming has nothing to do with the way that AWS routes traffic. So don't let that confuse you. I'm naming it the public subnet for my benefit, so I can remember how I've configured that subnet. But in order to make it a public subnet or private subnet, I have to configure the subnet properly. And let's do that now. We're going to go to our list of subnets, and we'll select the public subnet and click on the routing table. What we want to do is we want to edit the routing table that this subnet is associated with. I click on that routing table. Here's my routing table ID. It's associated with my class VPC, and it's what we call the main routing table or the default routing table for that VPC. Every subnet that I create by default will be associated with this main routing table unless I explicitly associate a subnet with a different routing table, which you'll see me do here shortly. This main routing table will have a set of routes. In this case, it only has one route, which is to route traffic locally within the VPC. We're going to edit the routing table. We're going to add a new route. And the new route we add says that we want to, if the traffic isn't destined for a resource within the VPC, we want all that traffic to be routed out through the internet gateway because it's probably destined for the internet. I'll use 0.0.0.0/0 to designate that all other traffic should be routed, and I wanted to target an internet gateway, and specifically the class internet gateway. That route looks good, so I will save the routes. And now you see that that main routing table has a route allowing access out to the internet through the internet gateway. Essentially, then, that makes this subnet a public subnet because it's able to route traffic out through the internet gateway. If I were to launch something like an EC2 instance or a NAT gateway, that those resources need to have public IP addresses attached to them in order to actually route through the internet gateway. But as long as they are deployed into that public subnet, they can now route traffic out to the internet through the internet gateway. Okay. Well, we still have this private subnet. And the private subnet, if I click on the route table, the private subnet, look at the routing. Because the private subnet is currently associated with the main routing table, it's going to inherit the same set of routes. Right now, my so-called private subnet is routing traffic out through the internet gateway, meaning that it's not really a private subnet. Again, just because I name it the class private subnet does not make it private. It's the configuration which makes it private. And I've inadvertently now made that class private subnet a public subnet, in effect, because it's able to route traffic out through the internet gateway. Well, let's fix that. And we're going to fix that by going to our routing table, and we're going to create a new routing table. And we're going to call it our class private routing table. We'll associate it with our class VPC. We'll go ahead and create it. We now have a class private routing table. It's not the main routing table. You can see that here. And I'm going to click on that routing table. And the first thing I'm going to do is create a subnet association. I want to associate it with my class private subnet, so that this class private subnet is going to be explicitly associated with this particular routing table. Now I've changed that association. My class private routing table is no longer associated with the default main routing table, and it will inherit whatever rules are set up within this routing table. And let's modify those rules now. And you see that there's a default rule, which is going to route traffic within the VPC locally, the local VPC network. We want to edit this route. We want to add a route. In this case, we want to route traffic that's destined for the internet through our NAT gateway. We'll select the NAT gateway that we created and save the route. I now have two routing tables, each one which is associated with a different subnet. The public subnet is associated with the main routing table. My private subnet is associated with this new class private subnet that I've created. Okay. And I've set up the routing properly for each of those routing tables. Let's go to our EC2 console and launch an EC2 instance into each subnet. I'm going to go ahead and launch an instance. I'm just going to make this an Amazon Linux 2 instance, a T2 micro, configure instance details. And up until this point, you've been sort of ignoring many of these network settings. Now, since we've created our own custom VPC, we want to make sure that we launch our EC2 instance and specify our class VPC. I'm going to launch this one into the class public subnet. And I'm going to use pay attention to this auto-assign public IP address. Currently, my class public subnet is not going to automatically assign public IP addresses. This is actually a setting I can change. the subnet configuration if I wanted to. In this case, I'm just going to say enable public IP for that EC2 instance that I launch. Next, I am look at the other settings. My tenancy is going to be shared, which is what I want, of course, which is based on my VPC. So everything else looks good. I'm going to click Next, add storage. I don't want to add, really don't need to add any storage. Next, add tags. I'm going to add a tag and call this my public. I'm going to call it the name. The key will be name. And the value, I'm going to say public server. Configure a security group. The only thing I'm going to do at this point is I'm going to allow incoming SSH. I'm just going to leave this security group for now. And say review and launch. And actually, let's go back to this security group. Let's create a new security group, and we're just going to call it we'll call it the public servers group. And you'll see why I'm doing this here in a bit. We're going to just do the VPC hands-on project public servers, and we'll just keep the same security group. SSH incoming from port 22, currently from the world, which is a bad idea. We're not going to do this ever in a business situation, and there are better ways to deal with this. But for this hands-on, this is fine for now. We're going to review and launch, and looks good. So we'll launch that EC2 instance and choose our key pair. Okay. Go to view instances, and our instance is going to be running here shortly. So it's starting up our instance. Let's go ahead and launch another instance. Again, Amazon Linux 2, T2 Micro. We're going to launch it into our class VPC. In this case, we're going to launch it into the private subnet. And we're not going to assign a public IP address. So it should disable. It should only have a private IP address. Go ahead and add storage. Just leave that as default. We'll add a tag and call it name private server. Next, configure security group, and we're going to call this our private server security group VPC hands-on project. And we're going to allow SSH traffic, but instead of allowing it from everywhere on the internet, what we're going to do is allow it from another security group. So I'm going to type in SG, and then I want to select that public servers security group. In other words, I will allow incoming SSH, incoming shell traffic, but only if it's originating from an EC2 instance that is associated with the public server security group. I'll go ahead and review and launch, and then I will launch that second EC2 instance. And while that's launching, I will pause here briefly. EC2 instances are now up and running. And what I want to do is I just want to shell into my public EC2 instance. I go click on my public EC2 instance. I have a public IP address, which I will copy, and then I will use a terminal application to shell into that instance. So I'll do SSH -I, specify my key that I'll use, and then I'm going to log in as ec2-user at the public IP address. And I'm able to successfully log into that public EC2 instance. However, the question is, how do I log into the private server? The private server doesn't have a public IP address. It only has a private IP address. It lives in the private subnet, meaning that I cannot initiate a request from the internet to connect to that server. It will not route my request through the NAT gateway to that server. The NAT gateway will only route traffic out from that EC2 instance. So in order to access that private EC2 instance, I need to essentially route that traffic through the public EC2 instance. I'll use the public EC2 instance as what we call a bastion host or a jump box. I will log into the public EC2 instance first, and then from that instance, I will jump to, or I will shell into, the private EC2 instance. And the way I do that using my terminal application is I will use a special SSH agent feature that's available to me. So I'll exit out of that public instance, and what I will do is I will add my local key that I'm using to the SSH agent key store, essentially, using the SSH-add command. I'll add that key, and then I'm going to shell back into that public server. But when I do that, I'm going to add a special flag, -A, capital A. And that's saying when you connect to the server, use the agent, because we're going to tunnel through this server to access other servers within the VPC network. So I access now the public server. Now I want to connect to the private server. In order to do that, I need to have the private IP address. I'm going to copy that private IP address. So I'm currently logged into the public server. From that public server, I want to connect to the private server. So I'm going to SSH ec2-user to the private IP address for that private server. Now notice I'm not specifying a key here. And that's because it will use the same key that I use to access the public server. It will pass that on when authenticating and connecting to the private server automatically for me. I do that, and voila, I am now logged into the private server. And I'm tunneling through the public server in order to do it. To prove that the private server is able to communicate out to the internet through the NAT gateway, I'm just going to issue the curl command and access something like the Google homepage. And there it responds back with all the HTML for the Google homepage. So the private server is able to access the internet, and it's doing so through that NAT gateway. I hope that this tutorial provides you with a good understanding of how to wire up the different components within a VPC. I know that this can be challenging. I strongly recommend that you perform this hands-on segment a few times until you feel really comfortable with configuring these different components, because you'll need to do this a number of times in future assignments and in future projects. Now, the last thing to remember is that you need to delete all of these resources and clean up after yourself now that you're done with the project. So make sure you terminate the EC2 instances and you delete the security groups that you set up. Make sure you also remove and delete all of the NAT Gateway, the elastic IP address, and all of the different VPC components that were created.